Hello, Math 10. Thank you, Mrs. Bachin, for looking after my guys today. Math 10, we're just continuing our journey with simple trinomials. Last day, you guys played the I win sum and product game, and in the assignment, you might have noticed that the only thing you did was positive products. And so part two, you actually are going to do the sum and product game, simple trinomials, with negative products. So that's the only thing that happens new here. Just a reminder that what we're solving here is the 1x squared simple trinomial. And because your type of formula only has a 1x squared, you have a much simpler sort of strategy. In order to factor these, all we need to look for is the sum of the middle term and the product of that last term. So we need to find those two integers. So last day we did questions like this where we had a positive product and sum. So in this case, we need to find two numbers whose product is 9 and whose sum is 6. And those two numbers are obviously going to be 3 and 3. But in the next one, we have a product of minus 12 and a sum of positive 1. And we talked about that. In order for that to happen, remember what we talked about? When you write out the products of just plain 12, you get 1 and 12, 2 and 6, 3 and 4, and then you start to repeat yourself, so there's no sense going any farther. The numbers, when you have a negative product, review how we talked about it, when you have a negative product, you're looking for two numbers that have a difference of 1, and therefore those numbers are 3 and 4, and specifically they would have to be a minus 4, no, a positive 4 and a minus 3, so that they would multiply to give you minus 12 and add up to positive 1, okay? So we talk about that, and we did that in the I win game. For a positive sum, they're both positive or both negative. If the product is negative, you've got a difference, one positive and one negative, okay? So the next one, maybe you can already play the game and then come back. So I'll just pause the thing, Mrs. Bachin, and they should be able to do these. So go and play the sum and product game, and then come back and see if you got the answers right. So in this one, we write out the factors. What do I know? I know that it's an x and an x, because it's a 1x squared. What are the numbers? The numbers for there to be a minus 1 and a minus 12 product is a minus 4 and a positive 3. And that is done. For question B, I can write out the factors. I know that it's this times this, and it's going to be an x and an x. And what would the numbers be that have that product and that sum? Well, minus 18 and 3, that's going to be a positive 6 and a minus 3. How about a squared minus 7a minus 8? You guys have tried that one. We've got to multiply that out. That's going to be an a and an a. And to have a minus 8 and a minus 7 sum and product, those two numbers must have been a minus 8 and a positive 1. And all was good in the land, right? Now, those are the basics. Not everything is factorable. So notice it says factor where possible. Sometimes the sum and product just doesn't work. And sometimes you got to watch out. It might not be simple. So in the first question we go, oh, okay, is there that sum and product? Let me think about it before I go and start factoring. Does that actually work? Well, I think a minus 9, whoopsie, no, a positive 9 and a minus 3 would give you that sum and difference. Sorry, that sum and product. We go back and we factor it, and we get a plus 9 and a minus 3. And we check it, do a quick inspection, but it looks like that's going to work. We go to the next one and we go, ooh, we got to make sure we watch that this is not a simple trinomial. This is actually a tough trinomial, or something that doesn't have a 1t squared. So the first thing we have to do is factor out the common factor first. So I can take out a 2, and now I'm left with t squared minus 7t plus 10. And now I can play the sum and product game. I know that I have a sum equal to minus 7 and a product equal to 10. Are there numbers that do that? And it looks to me like the two numbers that do that are a positive. We have a positive 10, so I must have a minus 5 and a minus 2. And now I can factor that one step farther, so I have 2 times t minus 5 and t minus 2. I want you to factor the next two out and then come back and see if you got the answer right. Hey, you're back. I'm sure you're done by now. So now we check this out and we say, what has a sum of minus 3 and a product of minus 6? You stand, you look, you scratch your head. No. Does not factor. This is not possible. That just doesn't work. Okay, you move to D and you say, whoa, that is not a simple trinomial. That is not a 1x squared thing. I can't do that. I have no tool for that. But the first thing I do is look for a common factor. And I do have a common factor. I can take out a 4x squared. And when I do that, I am left with x squared minus 4x and a minus 5. We now take that farther and I look for my sum and product, and my sum of minus 5 and product, my sum of minus 4 and product of minus 5 ends up being x minus 5 and x plus 1, because that had a sum of minus 4 and a product of minus 5. My numbers were minus 5 and 1. Okay? And you can always check to make sure that works. Lastly, you need to make sure that you are able to factor things that are a little weird. So notice that x plus 2 times x plus 4, it expands to be x squared plus 6x plus 8. And so the factors are x plus 4 and x plus 2. This one, when you expand it, you get something that looks a little weird. You get x's and y's and xy's. So when you expand this, you get x squared plus 6xy plus 8y squared. Notice it's just different because you've added that y on the end, so it creates a y and a y squared that you didn't have in the first example. They look the same, but they just have more variables, right? So x squared plus 6xy plus 8y squared can be factored to be x plus 4y and x plus 2y. So we just need to make sure that we're aware that adding variables makes things look a little strange, okay? So I want you to factor the next ones and see where you can go with that. Hopefully you didn't copy that down before I erased it. But now you come back and you say, well, this is a 1x squared. This is a 1x squared. Ooh, this one's not a 1x squared. Ooh. Okay, so we'll be careful with that one. But this is just a 1x squared with extra variables. So all I want you to do is consider that the sum is equal to 13 and the product is equal to 30. And now I go and find two numbers that do that. So I know that it's going to be an x times an x. And a sum of 13 and a product of 30, I think I'm going to have a plus 10y, because it's y squared at the back, and a plus 3y, because it's y at the back, okay? And that's that. In the middle, you again have a 1x squared, but the sum is 71 and the product is negative 72. Ooh, a negative product. So we have an x times x is x squared. And what are my two numbers? I think my two numbers are going to be plus 72y and minus 1y. Right? Just because my sum and product game gives me positive 72 and minus 1, right? And you need to have those y's because of that new variable. And lastly, ooh, we have not a 1 there, so the first thing I do is take out the greatest common factor, and I get 3. You can't take out an a, that's the most. I take out a 3, and I have a squared minus 5, minus 5ab, and whoa, I can't take out a, oh, can I? Okay, the last one's a little bit of a doozer. So you took out the 3 and you got 3a squared minus 5ab minus 84b squared. So you took out the sum, it's got the common factor. Now you have a sum minus 5 minus 84, and now we carry on, and now we need to find those numbers, and that's a tricky number, but it ends up being 3 bracket a minus, in this case we have a minus 12b and a plus 7b, because our magic numbers for that sum and product was minus 12 and positive 7. Okay, I want you to finish off lesson 4 assignment, and we will see you tomorrow.